everyone. My name is Muhammad Arif. I'll be hosting this session for this EMS. Uh, so we will just wait for like a couple of seconds and we will begin then our session. I see there are like 10 attendees. All right. So you all can see my screen. My voice is perfectly fine. We can begin our session. All right. I hope everything is well. Okay. So first of all, thank you for your presence. Today we are gathered here for energy management system using industrial Internet of Things. In a short, it's known as EMS system. Me, myself, my name is Muhammad Ali Tahir. I'm IoT consultant, and with us, Mr. Abdullah Sana. He's CEO of Tulip Technologies. So we will begin our session. Now, before we begin, we need to understand what is energy management system. So basically, it is a platform where we can uh, do the costing, monitoring, control, and optimize energy. So what it means, you can have a dashboard like this one. Here, you can have like monthly bill. You can know what is the monthly consumption. You can have invoices, and you can see and monitor that how many devices are online. And also, you have the like a comparison that what was the bill last month, what's the bill in this month, and the history. And also, you can have total consumptions. For example, maybe this one is chiller, for example, and this might be, for example, compressors. This might be, for example, lighting system. And how much is the total cost for the months, right? So this energy management system, it gives you this benefit. One of them is the costing. Another benefit, you can do the monitoring for the power quality. So, like for example, you will have all the parameters like voltage, current, kilowatt, and reactive power, power factor. Also, you can see the harmonic profile, that what is the harmonic profile, and you can connect other equipment for the quality purpose, like temperature, maybe air pressure. There can be humidity also. So, costing we covered, and monitoring also it can do. And what else? It can do the control also. So what it means that if you have certain outputs, certain inputs which you want to have it as a feedback or you want to give signal, that's also possible through EMS system. And you can optimize the energy. Now the key question is that if you cannot measure, how you can manage. So if you have the measurement, which tells you what was the energy previously and what is the energy afterwards, after some improvement, that's where you can know how much you managed. So for example, this is one of the examples that you have a system without jacket and you have a system with jacket, and you can see how much is the reduction. So based on this reduction, you can actually know what is the ROI of improvement. And same goes for the motor. uh, for the motor um, uh, after the improvement by installing the vibration sensor. You can actually measure and you can know before time if there is any problem with the bearing or any other mechanical issues. Um, so and because the system it has historical data, so you can just compare two different values like it has shown here, which will give you a good analysis that what's the improvement. Okay, so now we know what energy management system can do, but the key question is why we need energy management system. So one of the benefits of energy management system, you can track the energy and you can actually reduce the wastage by making some changes in the network. Energy tracking, it's possible. You can use this EMS system for budget forecast. If you have a certain number of protection, you can actually forecast that how much energy is going to be used and what will be the cost of that energy. So you have a forecast in advance. You can do predictive maintenance. Uh, you will have a database for energy quality. So let's say there is a voltage fluctuation, for example, or uh, 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 like a voltage drop, for example, it can be monitored and it can be stored. If there is, for example, overcurrent issue, it can be stored. So that means you have a database and you can implement a billing system also. So what to measure? Now, for example, production cost. So for the factory, production cost is very important. Uh, so what I need to know that how much is this machine consuming? What is the cost of energy? How much is the production duration? How many labors are working? The material used and the cost. That will give me the complete production cost. So for that purpose, I can have like multiple machines or connected on the distribution board. I can have meters for each machine, which will give me the key parameter like kilowatt hour. And I can use a power quality meter at the main distribution board that will just keep a track of like voltage, current, and many things like harmonics, for example. And so this system will be beneficial to let me know what is the actual cost of production. So what else? I can do the billing system. So that means um, if I have different plants, different transformers, I can keep a track in much efficient way because I'll not have just the kilowatt hour. I'll have the cost plus I'll have other parameters like waste energy and other parameters which are like power quality parameters that will also be traced. I can use this EMS system for quality monitoring. So, for example, I can keep a track of temperature and humidity in the database. So, temperature and humidity. And I can keep a track of liquid or gas if there is any leakage by connecting the leakage sensor to the EMS system. So what else we can do? Predictive maintenance. So we have power quality meter, which can monitor, especially for example, the voltage drops, for example, the voltage rise, for example, and that will help me to predict if there is anything wrong with the grid, which can potentially trip the grid and trip the system because of the protection release. And I can have some sensors like vibration sensors connected on the motor. So this is going to enable me to make a predictive maintenance. And uh, there are more such sensors which can be connected, such as leakage sensors, for example. So that can also be connected. So, or any such as a sensor which will help me in predictive maintenance. All right. So I will show you the demo. Um, just 1 minute. Let me share the screen. So before moving on, we have two platforms which we offer. We have one platform, it's from Clemson, it's known as KIO. We have another platform which is Deconnect. This is a platform which we developed it in Saudi. I will show you both of these platforms. Now, this is the platform which is known as Deconnect. I'm going to log out from this platform and log in to give you an idea um, that how this platform looks like. All right. So in this platform, we have uh, a total three modules. One module is smart energy, another module is smart water, and the third module is smart cities. So in smart energy, I can monitor the energy, I can monitor the quality of energy, and I can monitor especially the power factor. In smart water, I can connect the water pumps to this platform, which will help me monitor uh, the the flow, the working cycle, all these things. And smart cities, that is for city application. So in energy, as you can see here, uh, we can do the billing system. We can connect the meters, and we can assign the name of the location for those billing system, and that will give me an overview for the bills. Um, Plus, I can install, I can show those on the map. If you have different facilities at different places, that can be shown on the map. And asset management, which means you can have a meter for different machines, and you can name that one. So it will show here. Plus, there is analytics, which will show you the monthly consumption, what was previous months, what was before that. So, like a historical data. And you have alarms. So, this was about the billing system. Then we have another module, which is to monitor the health of the capacitor bank, which is installed. So it will monitor the health of the capacitor bank, and it will let you know uh, how much it remained to the target. Um, so this is what we have in the Connect Smart Energy. Then we have Smart Water. In Smart Water, we can connect the booster pumps, and those booster pumps are going to give you the data about its running cycle, about the history, so you can do the monitoring for that. Then we have another platform. This is known as KIO platform. This is a demo version. And here you can see uh, in this platform, there are 197 devices, 149 devices are online, 15 devices are passive, which means it is connected, but I have kept it offline for some reason. And 31 devices, they lost their communication. Uh, so how it looks like, this is the organization chart. Here you can see different devices which are connected. You can assign the areas, like for example, chiller area, compressor area, office area, and you can do the individual monitoring. Plus, we have the mimic feature, which means I can have your client as a 3D in this platform, and I can do the monitoring. So whether 3D or 2D, both are possible in this mimic. And of course, we have the map feature also. In the map feature, we can monitor the devices which are at different locations. So if you have factories which are in different locations in Saudi Arabia, you can use this feature and you can easily go to that factory through a cloud connectivity. And there are other features like graphical representation and so on. For say, reporting also, you can have a report generation. You can track the CO2 which your factory is producing and how much trees you want to implement to comply with ISO 50001. And of course, there is invoice management system. So that's a very short demo for our platform. Now, I would like to know if you have any questions so far. So after that, we can carry on. Okay. So I see one question that if we have a gas meter, yes, we can arrange. We have some partners who can produce gas and liquid meters. So we can arrange after you give us some, you can provide us the requirement, and based on that one, we can provide you the gas meter. Any other questions? All right. So now moving to the next step. So anything which is not clear, any questions, feel free to ask us. So moving on, how to make these things possible? Uh, because we have like different devices, there might be different connection method. So how to really make it possible? Now, devices, which device can be connected to EMS? Any device which can communicate. So if the device, it has, for example, Modbus connectivity, it's very easy to install. So whether this device is meter, whether this device is temperature controller, humidity controller, or a flow sensor, for example, it can be connected. So what type of connectivity? There can be two types of connectivity, wired connectivity and wireless connectivity. So if you have application which is not critical, then you can go for wireless connectivity. For the wireless connectivity, excuse me, I will show you. For the wireless connectivity, we have LoRaWAN. For the LoRaWAN, it can cover as an indoor, it can cover approximately 1 to 2 kilometer. So and that means completely wireless. What it means that I have a central station, uh, or let's call it server, and I have devices, device one, device two, device three. They can communicate with this master device using wireless connectivity. 1 to 2 kilometers is a possibility. Then we have other type of connectivity, for example, Ethernet. So let's say in your room, there is already a Ethernet switch, and we then we can have a type of device which can connect, especially for power quality, which can connect with just using the Ethernet cable. So maximum for this cable, it can be 100 meters. But in any case, let's say you want a wide solution, or we think wide solution is the best possibility for your application, then we can offer a daisy chain uh, type of connectivity, which can be up to 700 meters. And it can be used for 31 devices. Normally, we take 31 devices in a loop, or we can have a repeater to extend. Now, after this connectivity at the device level, then comes the gateway. So these gateways can be like this one. Basically, a gateway is a protocol converter. So the devices which are at the side, it might be, for example, Modbus. So this might be Modbus, and this Modbus need to be connected to something which a computer can read. So it is going to convert it into Ethernet. And if we have a device which already has Ethernet connectivity, it can be just connected to a switch, and this switch can be connected to a central system. And in this hardware, we have multiple options. It can be wired option like Ethernet. That's one of the possibility. Or we can have GSM, which is like 4G. So that's another possibility. And at the end, you have two options. One option is to have a local system, which is also known as on-premises. And you have another option, which is known as cloud. So what it means that you have different facilities and you want to connect to one platform, you can go for a cloud system. So it will give you a facility that you from anywhere in the world you can access your devices. If you do not want to access from anywhere in the world, or you just want to have a local system which you want to just you know, connect from within the facility, then you can go for local or on-premises system. Now, what type of devices? Uh, we have power quality device, we have normal energy meters. You just name it, any meter for electrical parameter, we have such device. Then the next one for the quality purpose, like temperature, humidity controller, we have that device also. If you need to monitor the count of the product, you want to connect the counter to our system, yes, it's also possible. And we have these counters which can communicate. And lastly, if you have any other device, it might be your existing flow sensor, it might be VFD, it can be any other device which can communicate. It's possible to integrate in our platforms. So we covered devices. Devices done. Next is the gateway. So if you have RS-485, if we provide or you intend for RS-485 connectivity, you can go for a cable length of 700 meters, and you can connect 31 devices in a loop. The connection method is daisy chain. Um, if we provide or you request for Ethernet connectivity, its connection will be star protocol. Each cable will be connected as 100 meter, and many connections are possible using this method. So, and lastly, now these two methods, these are known as wired methods, and LoRaWAN we have is wireless. So this technology, it works on radio signals, and it can cover 1 to 2 kilometers indoor. And if it is outdoor, it can cover 15 meters. And regarding the communication protocols, we can connect our system using Modbus. We can connect our system using MQTT. And also, one more thing, if you want to connect to SCADA system, there's also possibility using OPC. So that's end of the presentation and end of our demo. Do let us know if you have any questions. We will be happy to answer. All right, we have a question that is it must that the hardware, the device, and the gateway has to be matching with a software platform? No, it can be from different vendors also. So let's say you have existing device and you want to integrate to our system. Yes, there is a possibility. Only condition is that it should have Modbus option, Modbus connectivity, or for example, OPC connectivity or MQTT can be enabled. So that one, once enabled, it can be integrated. So there is another question. Um, System can accept sensors or meters like vibration sensor, speed sensor. Yes, it can accept. And our platform, it has two types of method to collect the data. One method is like historical method, which means like temperature. It will just check the temperature each hour, and based on that one, it will save the logs. But when it comes to the counter, that means, or for example, RPM sensor, that means it doesn't have to be stored. It has to just know the value at that moment. So that's also a possibility. It can be connected. Okay. So one question is asked, can it be integrated to ERP system? For this one, we can check with our original supplier. You can send us the detail. and we will ask our supplier if they can integrate. I'm sure if other platform can be connected, then our platform can also be connected, but it will not be a default feature. I will have to ask our software developer to facilitate for that one. Okay, so there is another question. System access can be through local or cloud. So we have two type of system. One is the local, which means the software for the one time it is going to be installed in your system and it will be there forever. But the only thing is it has to be accessed locally within the premises and from the same computer which is licensed. When it comes to cloud, we are going to provide you a cloud system so you can just, like any website, you can just enter on the browser and you will have your own username and password. And plus, there will be security code. So you will type those things and then you can have the access to your devices from anywhere in the world. Okay, there is another question. Modbus has limited distance to interconnect between devices. No, for the Modbus, it has to be just 700 meters. Now, in this 700 meters, it can be one device or it can be multiple devices, like 31 devices. So it's a possibility. The only catch here is that we just make the setting for the baud rate. So, for example, for 700 meters, our baud rate will be 9,600. Um, and we have tested this one, and it's perfectly fine. In case the length need to be extended, there is option that we can use a repeater, Modbus repeater. Okay. So there is question. What is the AWG for Modbus cable? I recommend not to use a normal cable. There is one special cable for Modbus. Um, and this cable is shielded, and you can find it if you, for example, write RS485 cable. You can find that cable. It is a shielded cable. It is twisted, so it reduces any type of noise which can come from the power lines because this Modbus usually it works in very low voltage. So we need to keep the line as clean as possible. So I recommend to use a special cable which is for RS communication. It will be twisted pair and with shield.